Howdy folks, Mr. Reed here, and welcome to One More Question. So for today, what we're going to be taking a look at are horizontal and vertical stretches and reflections. We're going to be doing them graph to graph. So I'm going to have a picture of a graph and a second transformed graph. We're going to try to find out the algebraic link that takes us from the original onto the transformed function. So we're going to be doing that at a medium level today. It's going to involve probably both stretches and at least one reflection. So let's get to it. All right, so now that you can see the graphs, it's the same original f of x function that I've used in a couple videos so far, or one, I guess it is. And the transformed version is going to look a little bit different, but it's kind of got the same sort of thing going on there. So every time you only do stretches, reflections, and translations once we cook them in with the rest of them, you're going to find that the functions always look the same. Sure, they're going to be different in terms of their size or where they're placed, but you're not going to suddenly go from something that's piecewise and it's kind of like these three bars that are connected together, like the f of x function, three little linear line segments, I guess we should call them. And you're not going to see that all of a sudden it curves or does something weird. So these sets of transformations are fairly basic and aren't going to alter the shape of the function in any way other than just moving and making things bigger on one of two axes. So in this particular case, let's start right off by saying generally a g of x function can be described as a transformation of an f of x function if we are only using stretches and reflections by placing an a coefficient on the front of the function and a b coefficient inside of the argument of the function. If you followed along with some of the videos that I've done so far, you'll know that A, or you might know from elsewhere, you'll know that the A is going to take care of the vertical stretch and or potentially reflections, and the B is going to take care of the horizontal stretch and or reflections. So let's go ahead and analyze the two graphs and kind of get an idea of how we're going to match them up so we can start doing a comparison. So the first thing that I'm going to do is actually, I guess, label the points so that you and I are both feeling confident about which points on my original function are associated with the certain points on the transform function. So I'm going to call this point over here A. I don't know if that shows up real well in the white, but I'm going to go with it because the labeling's not super important, but it is what it is. So A for that one, and that is on the end of the short arm. If I follow along the g function, the end of the short arm is right here. So that's a prime if I want to, or other a if you wish. So that's all I mean by that prime notation. This one right here, if I call that b, then that's at the end of the short arm, so that's b prime. The one at the origin is funny because things at the origin are actually always invariant under any stretch or reflection. So if we take something that's right on 0, 0 at the origin and we say, hey, do a reflection, it's going to stay there. This other reflection, stay there. Stretch away from the axis, well, it's at 0. So multiplying it by any multiplicative number is going to leave you at 0 anyway, this way or this way. So it's totally invariant under all of the transformations that we're talking about right now. So it should be not just okay that it's at the origin, it should be obvious that it's going to be left there at the origin. The only other point that we have here is the one that's down here. I'm going to call that D. And it is going to go along with this D prime that is up on the other side there. So what I would like to do now is I'm going to actually compare A to A prime. So right now, A is below a horizontal line portion of the f of x function. So the horizontal line's on top, A is below, and A suddenly on the new function is above. So g of x has the horizontal portion of it lower and the A part higher. You can't reorder things top to bottom by stretching. So stretching just makes things get bigger like this, or I mean like this, but that's obviously not going to do anything from a vertical point of view. The only way to do that is to get a reflection involved. So there must be a top to bottom, which is a vertical reflection in this particular case. So I'm going to just kind of summarize the things that we are finding out over on the side. So we have found that there is a vertical reflection. I'm going to start being really lazy with that. I'm going to call it VR. So we have found that there is a VR going on in this particular case. Another thing we can do is say, okay, well, once we know that the VR has gone on, it's like that the point is actually at 4, 1 instead of being at 4, -1, because the transformation part of it is going to move it on to the other side of the axis there. We're going to get our flip. So once it's there, it's still not in the right place. A prime is where we need to be, but the A value our transformation has only brought us to 4, 1, and that's because there must be some sort of stretches involved here too. Now we can tell this by looking at the point and realizing, well, it's at 4 and we need it to be out at 8, so that is a horizontal stretch by a factor of 2, and it's up at 1 and it needs to be up at 2, which means we have a vertical stretch also by a factor of 2. Now, you can do it by looking at the point and seeing where it needs to go. That becomes a little less helpful if you are looking at translations being involved, but for the time being, since we're only doing stretches, then it's okay. Another way to do it, which is a little bit safer, is to pick out a section of your function and look at its size. So this little piece down here, which I called the little arm, I think, before, it's 1 unit wide and 1 unit tall. So the 1 unit wide is the horizontal length of it, and it needs to become this piece over here, which is 2 units wide and 2 units tall. So that means that that part has been stretched both horizontally and vertically, both from 1 to 2 and 1 to 2. It's the same thing both times. So you have the horizontal stretch of 2, the vertical stretch of 2. Once we have that stuff figured out kind of in a word description sense, we can go to attempt to mark this off algebraically, finish off the question by writing down what g of x is in terms of transformations of the f function. So how do we describe a vertical reflection? That is a negative sign that's associated with the a parameter, which controls vertical stuff. So we need a negative out front where that a is. But it's not just negative or -1, it also is doing a vertical stretch there, and that's a vertical stretch by a factor of 2. So we'll have -2. That a value is done, and now we go into f of bx. So that b value is the b value that will cause a stretch of 2. This, again, there's nothing you can really do about this other than probably just make sure you're comfortable with it and memorize it. The idea is that b values are not the horizontal stretch. They are the reciprocal of the horizontal stretch. So it's really helpful if you can see whole numbers as being fractions very easily. So in this case, 2 over 1. So you have 2 over 1, the reciprocal of which is 1 over 2. So we'd have a b value here of 1 over 2 times the x, finish it off. And so this g of x function, in this case, is equal to -2 onto the original function f, and then inside the argument 1/2 x. And so this is an example that had both a horizontal and a vertical stretch. It also had a vertical reflection, and so you get a kind of a mix of these things going on in here. So that's probably as much as I'll do with the graph-to-graph idea. Don't think we're quite to the type of question that allows us to get spicy on these things. But if that was helpful to you and you'd like to let me know, like, subscribe. If there were some errors or problems or you just want to get in touch, please feel free to use some of the details in the description below. As always, take care, folks.